So in this presentation, I will talk about how to use Microsoft Azure as a platform to construct the MLOps pipeline. In this platform, the major service I will use is the Azure ML, which is Azure Machine Learning. Using Azure ML, I imported the datasets, constructed the pipeline, did the automated ML jobs, built a data drift monitor, and selected compute clusters and inference clusters. In Microsoft Azure, here we need to create a resource group before we formally start to use the Azure Machine Learning service. From the resource group, we can see that I have a resource group called 2205A3, and this will be the resource group for this project. Initially, we don't have anything inside this resource group. So we need to create an environment for Azure Machine Learning. After all settings are done and waiting for a while, we can see that the Azure ML deployment is ready. After the deployment, it is time for us to get into the environment. Now we click the Launch Studio. The first thing to do in this environment is to click Import the datasets. Here, I will still use two wine quality datasets talked about in the class. We can see that there are multiple ways to import the datasets. The most common here is to use the local files. Keep all settings as a default value. We can finish the setting and import the datasets. The previous dataset is used to train the dataset. We still need one more dataset, which is supposed to use for inference for scoring. So all steps are same to the previous datasets. Now we have two datasets ready and can go to the next stage. After importing these two datasets, it is time to select the appropriate compute instance to do the computation work. Moreover, in order to deal with large amounts of data, we may need to use a cluster, which is basically a collection of computational resources. In the stage of training, most times we will need to use GPU to do matrix mathematics. However, when it comes to the inference time, it is a much simpler calculation. Hence, we do not need to pay for a GPU anymore. Here, I choose the DS3V2 in the CPU as a compute cluster. After finishing the setting, the compute cluster is ready. So beside the compute instances, we still need the inference cluster, and sometimes it is shown as the Kubernetes clusters in Azure. So most steps are similar. Here, I choose the A2V2 as my inference cluster. After setting up the datasets and two clusters, we need to formally construct the pipeline now. In the pipeline section from the left bar, we can see there are multiple components for us to choose. What we need to do is simply drag and drop to construct the pipeline. Obviously, we need to have our trained datasets. Next, we need to split the dataset into two groups, one for training and one for testing. Most times, the split ratio is 80% for training and 20% for testing. We can see that the split data components will have two outputs. The training outputs will come together with our chosen algorithm, like linear regression, to do the formal model training process. After training the model, the output will come together with our test dataset to the score model. The score model here will be used to generate the prediction. Finally, we will use the evaluate model component to evaluate the performance of our model. After adding all these basic components, I still need to revise the train model here to add the dependent variable. Here in the example of wine quality, apparently, the dependent variable here is the quality. Last but not least, don't forget to use the compute cluster we previously chose as the Azure ML compute cluster. And now we can click the submit to finish creating the pipeline. After we submit, the pipeline needs a while for running. After all components comes with a green check, it means the pipeline has finished running. Under the explanation section, we can see different graphs to evaluate the performance of the model by exploring the distributions of predictions values and the values of the model performance metrics. Also, we can select an individual data point to view its local feature importance values. Under the matrix section, the Azure ML also shows some critical values like coefficient, mean absolute error, and relative squared error. After we review the performance of the model, you can move further to the deployment stage. First, we need to register the model using the output of our trained model. So similarly, by keeping all values as the default, we can finish the setting easily. Also, we still have to have a real-time inference, and here we will use the inference cluster we previously choose. If we click on Create the inference pipeline, the following graph will automatically jump out. Based on the output, we need to make some adjustments and add some new components like the web service input and the selecting columns. The component of selecting columns is worth exploring here. It can help us choose all components except the quality. The purpose of this step is to balance two inputs, since the train test dataset has 12 columns, while another input here only has 11. So we need to exclude the quality column. Now we can submit this inference pipeline and go to create the real-time endpoint. Setting up the real-time endpoint is the last step for designing a MLOps pipeline using the GUI. It allows me to deploy and serve a trained machine learning model for real-time inference. Once deployed, the endpoint can be used to send requests to the model and receive predictions in real time. So all my previous work helped us design the basic MLOps pipeline. What I'm going to do next is more close to the deployment and adding more components to this pipeline, like the data drift monitor, so that our pipeline can be more effective in the real-world project. Here, the service I'm going to use is the automated ML. When we are going to create an automated ML job, the first thing is still selecting the database. Next, we are still going to use the previous compute cluster to do the computing work. So in this automated ML task, we select the regression since we want to predict the quality of wine. Finally, select the auto validation. Now, the automated ML setting is finished. The purpose of doing the automated ML job is to automate the process of building and training machine learning models in a more efficient and faster way by automating the tasks of selecting algorithms, tuning hyperparameters, and evaluating model performance. Based on the multiple results it provided, we will select the one with the best performance to deploy. In the section of child jobs here, we can see that few of them have finished running and some of them are still waiting for running. As long as all of them are finished, we can compare the performance and make the decision. For example, if we randomly choose one job called tender avocado, from here we can see the training algorithm it's used and the other related hyperparameters. Next, I want to create a model explanation job for this model to better evaluate its performance. So after the model explanation job is finished, we can see some aggregate feature performance and individual feature performance, just like we evaluated the model performance before. So in terms of functionality, the scope of MLOps pipeline cannot be limited to those normal components we talked before. We also need to have other unique components like data drift monitors. Next, I'm going to add the data drift monitor to the pipeline in order to ensure that our ML models are providing accurate and reliable predictions, even as the data they are working with changes over time. Before adding the data drift monitor, we still need 2 more datasets with timestamp to simulate the data changing environment. So all things are similar to importing the normal datasets. So one thing need to be noticed is that we need to set the type of timestamp column to date and properties to timestamp and change the data format. After we have our dataset with timestamp, we can click Generate Profile and select our compute cluster to view some properties. And here is the generated profile. Besides the baseline timestamp datasets, we still need one more target timestamp dataset. So all steps are still same to importing the baseline timestamp dataset. So now we have our two timestamp datasets. So to create the data drift monitor, first we have to choose the target dataset, which is the second dataset we imported, and then select the first imported baseline dataset. Coming to the monitor setting, we need to set the computer cluster frequency and threshold. Finally, we have to set the start date and end date to submit a run to analyze existing data. So after finish running, inside the data category, we can click the dataset monitor to get into the performance of our monitor. First thing we can see is the data drift magnitude and other related features. Besides this, we can see there is a graph of drift magnitude trend under this data. So furthermore, we can see the drift magnitude by features and feature distributions. As of now, the design of my MLOps pipeline is finished. Obviously here, I only use the GUI to design the MLOps. The most important reason is that GUI is the easiest to use and proper for those rookies and startup companies who just get in touch with machine learning. The CLI and SDK is more complex since it needs more knowledge about commands and programming skills. Although CLI and SDK are very complex, it is still more proper for repetitive tasks since they can be automated and scripted. Specifically to SDK, it provides a high customization since it allows users to create custom solutions based on their needs. In conclusion, GUI is more proper for new users, while CLI and SDK is more proper for users requiring more flexibility and customization. So although I didn't show this in the PowerPoint, if we want to connect multiple phases of pipelines, we may use Azure DevOps to manage source code and deploy applications. When using Azure DevOps, SDK and CLI mechanism are two more proper ways than GUI. In Microsoft Azure, we also have other services other than Azure DevOps to connect multiple phases with each other. For example, Azure Function can allow us to run code on demand without provisioning or managing infrastructure. So when using Microsoft Azure, the most important takeaway for me is the high functionality facing the real-world deployment. Even using the GUI mechanism, Azure still provides a high flexibility like creating the data drift monitor. After creating such a pipeline by myself, I first recognized that we have to consider the problem of cost when we are facing a real-world problem. For example, we can not only consider the performance of our computer and inference cluster, but consider the cost when we choose those clusters. Especially for those small-scale companies, cost is definitely the most important consideration in designing MLOps pipeline. In designing the pipeline, the most intuitive activity for me is selecting the components and creating the data drift monitor. Actually, the convenience of GUI in Azure made my idea fresh in machine learning algorithm and in machine learning. Under the GUI mechanism, we can easily drag and drop our needed components like training algorithms and model evaluation components without doing any coding work. This did lower the barrier of entering the industry of machine learning. For the data drift monitor, it brings all theoretical ideas to the practical deployment. Facing the dynamic environments, the monitor did let us ensure the performance of our model. One thing I think which is worth improving is dealing with the original datasets. Most datasets we acquired now are messy and need some cleaning work. Azure did provide some mechanism for cleaning and pre-processing the datasets. However, this is not enough for dealing with those really complex datasets. Maybe some experts may use the mechanism of CLI and SDK to do the pre-processing work, but it is still hard for those rookies and the new users and to and the data cleaning is the most important process in the whole project. If we contain some dummy and ineffective data in our datasets, then our models and the predictions will all be biased. Adding some components help new users to clean or manipulate messy datasets can really improve the functionality of Azure. So that's my presentation. Thank you for your time.